Welcome back. We're in lesson 66 in Algebra 1. We're going to be talking about the simplification of radical expressions. So in lesson 63, we learned to simplify expressions such as the square root of 50 by using the product of square roots rule. And all that really was to tell us that if we factor this as a product of square roots, then we can factor out coefficients and reduce it to its smallest possible form and simplify it. So for instance, the square root of 50 would be the same thing as the square root of 2 times the square root of 25. Now the reason we pulled out 25 is because we know the square root of 25 is 5, right? So we could solve that. We could turn that into the coefficient 5. So the square root of 2 times 5 is equal to this, 5 times the square root of 2. We always put this as the variable behind the coefficient. So that's why we would do that, and that's how we do that. And if you're not sure about this, you can always just factor it out. So if it didn't occur to you on the front end that 25 was an option, you could have done something like this. Well, 5 times the square root of 10, right? And 10 is equal to, 5 times the square root of 10. 10 is 2 times the square root of 5. Oh, I've got two 5s. Those two 5s turn into one 5 because the square root of 5 times the square root of 5 is 5, right? So then you would still end up with 5 times the square root of 2. So if you don't see the perfect squares within the factors right away, it's okay. You can just factor it all the way out. All right, so let's do some practice problems and see what we do from there. So let's do 66.1. We are asked to simplify the square root of 18 plus the square root of 8. All right, so let's factor tree this. We know that 18 is 2 times 9, right? So the square root of 2 times the square root of 9. We know that 3 times 3 is 9. So 3 times the square root of 2 is going to be the same thing as the square root of 18. All right, that's this one taken care of. Now let's talk about 8. Square root of 8, we know we have 2 times 4 gives us 8. And we know the square root of 4 is a perfect square, so that's 2. So this becomes 2 times the square root of 2. Now that they both have the same square root base, we can add the coefficients together and we get 5 times the square root of 2. And that's how we simplify. We factor it out, solve what we can, and then try to find like terms that we can combine. Okay? So those are your steps. Factor, solve, combine like terms. All right, those are the 3 steps for all of these things that we do. Let's do 66.2, see what we got. All right, this says 8 times the square root of 27 minus 3 times the square root of 75. All right, so I'm looking at 27. I'm thinking about the factors of 27. The factors of 27 are 3 and 9. And I know that 9 is a perfect square. It's 3 times 3, right? So I can say that this is going to be 8 times the square root of 3 times the square root of 9, which is a 3. So 3 times 8 is 24, and I have a square root of 3 left. Bring down my operator. And so I have this one. I know that the factors of 75 are 3 times 25, right? And I know that 25 is a perfect square. So that tells me I've got 3 times the square root of 3 times the square root of 25, We know that solves to be 5, so 5 times 3 is 15 times the square root of 3. So now I have 24 minus 15. Both of them are square roots of 3. So they're like terms. So when I do the subtraction of 24 minus 15, I get 9 times the square root of 3 as my final answer. All right, see how that works? We factor, solve what we can, and then we combine like terms. Let's look at 66.3. We're going to simplify the square root of 27 minus 3 times the square root of 18 minus 6 times the square root of 45. So I want you guys to do this on your own first. Okay? Pause your video, solve, come back and check your answer. All right, so if you got the square root of, well, not the square root of, but 3 times the square root of 3 minus 9 times the square root of 2 minus 18 times the square root of 5, then you got the right answer, because that's as far as we could go. Even though we simplified them down, we could not get the same terms here. These are the smallest. These are the prime factors underneath the square root. That's all you can do. All right, very good. So let's look at the square roots of larger numbers. So let's say we have a really big number, or let's go back to 50. 50 is not a really big number, but when we do that, we see that we have the square root of 5 times the square root of 5 times the square root of 2, right? So we know we can combine these two together and get 5 times the square root of 2. It's kind of like negative negative makes a positive. The square root of a number times the square root of the same number equals that number as a whole coefficient. So we're going to do the same method to bigger numbers. So for instance, if we had, let's say we had 1,000, okay? We can see that it is going to be 10 cubed, right? Because 10 times 10 times 10 is 1,000. That's 3 zeros, 1, 2, 3. So we can take 2 of these out, and we have 10 times the square root of 10. Just based on the number of zeros, that's how many 10s we have. And if we have 2 of these paired together, we know we can pull them out in pairs, so that gives us a coefficient of 10. So let's try a really big number. Let's do example 1. Or example 4, 66.4. We are going to simplify the square root of 50,000. So we see 4 zeros. So we write the square root of 5 times the square root of 10,000. All right, 4 zeros. We know those 4 zeros are going to be 100 times 100, right? Because the square root of 100 times the square root of 100 gives us 10,000. So this becomes 100 times the square root of 5. Easy peasy. Okay, let's do 66.5. And we have the square root of 500,000. Well, now we have 5 zeros. So let's split that up into 4 zeros and 50. So we have 50 times 4 zeros. Right? So we know that 100 times 100, that's 4 zeros. So we can say 100 times the square root of 50. Well, 50 is 2 times square root of 2 times square root of 25. We know this becomes a 5. So 5 times 100, that's 500 times the square root of 2. How about that? All right, these are going to be so easy. You're going to kick yourself. You're going to be like, this isn't hard. Let's do some more. Let's do a really, really, really big number. Let's do a whole bunch of zeros. Let's do 40 million. Yes, I said million. So let's look at our zeros. So for every 2, we have 100, right? Well, we have 3 and 3 here. So for every 3, we have 1,000. So we know we can pull 1,000 out. So that's going to be 1,000 times the square root of 40, right? Because we paired up our zeros. We said, let me scooch back a bit. We said the square root of 40 times the square root of 1,000 times the square root of 1,000, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then this one is all by himself. 40 can factor into square root of 4 times the square root of 10, right? Right. So we know that square root of 4 is 2. And we know that square root of a number times the square root of the same number is that number as a coefficient. So 2 times 1,000. And then all we have left is the square root of 10. So our number is going to be, or our answer is going to be 2,000 times the square root of 10. Okay? And this was 66.6. So I want you to try 66.7 on your own, and it is going to be a really big number. 700 million. Woo! Big number. All right, I want you guys to solve this one, 700 million, the square root of. Simplify it down. And then let's pause the video, you do that, and then come back and press play and see what we got. All right, so let's check our work. So first I realized that this was 700 million, right? So, and the million part is 1,000 times 1,000 because we got 3 zeros and 3 zeros. So very quickly I was able to get the square root of 1,000 twice, which gave me 1,000. Then I realized that this 700 bit, it was 700 times the square root of 1,000 times the square root of 1,000. Here, let me just solve it for you instead of showing you the aftermath. So I said the square root of 7 times the square root of 100 million first, right? And I realized that I had 3 zeros and 3 zeros. Well, if you look at it, it's actually 1, 2, 3, 4, 5, 6, 7, 8 zeros. So that's the square root of 7 times 1, 2, 3, 4 times the square root of 1, 2, 3, 4. Right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So those two cancel each other out to get 10,000. And then you still have the square root of 7 left over. And that's your answer. All right. And that's a little bit easier way to do it than what I had done before. Before I had just taken my 2 sets of 3, put them together, and then I did the 100 was 10 times 10. So this is actually a little bit more succinct. Let's see if we have any more to do. These are kind of fun. Nope, that's all we have. That was the last one. Let's do one more. I'm going to make up one more. 66.8. And we're going to do the square root of 80 billion. Yes. So 3 sets of 3 zeros. All right, so the first thing we see is we have the square root. This is the square root of 8. Right here, we can break that down into the square root of 2 times the square root of 4. That's 8. So now we have the square root of, I don't know why my pen's not writing. Oh, what did it do that for? All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. So that this one has 1, 2, 3, 4, 5. This one has 1, 2, 3, 4, 5. All right, so we have a number with 5 zeros. So that's going to be 100,000. There's my little comma. That helps me to have the commas. But 4 is a perfect square, so that becomes a 2. These together become 100,000. So 2 times 100,000 is 200,000 times the square root of the remaining square root of 2. And that would be the answer to this one. Easy peasy. All right, you guys kind of see how to use the zeros to count them, divide them by 2, and that becomes your two radicals that you multiply against each other to pull out a whole number or a coefficient to multiply against the rest. That's all we have for lesson 66. I will see you in lesson 67.